You've all heard of cancer. Cells dividing without even trying, not a single one hiding. When does this stop? There's no deciding. But have you heard of cancer cells that don't divide? I know, sounds weird. But scientists have recently discovered that inside tumors, there are some cells that just stop proliferating, entering the G0 phase of the cell cycle known as quiescence. And at first glance, that sounds great. The cancer's not growing. Problem solved. But as in everything else in life, there's a catch. Quiescence is reversible. So at any point in time, these cells can just start dividing again. And that's not all. You know how chemotherapy is normally used to treat cancer by targeting rapidly dividing cells? Well, when cancer cells enter quiescence, they naturally become resistant to chemotherapy because they aren't dividing. And that's fine. The issue is that when the cancer cells leave quiescence and start dividing again upon cancer relapse, they're still chemo-resistant, and scientists don't fully know why. That's a problem, especially since recent studies have shown that over 90% of cancer patient deaths is attributed to drug resistance. Even my mom, who suffered from stage 3 breast cancer when I was in middle school, is at risk of developing second-time cancer with resistance to chemotherapy. So if scientists can identify even a couple of proteins that play a role in causing chemo resistance, that'd be huge because we'd have something to target with therapeutics. And that's my goal with this project. After over a year of running Western blots, PCRs, and doing bioinformatic analysis and so much more, we've stumbled upon some really interesting findings. For example, we've identified a set of mitochondrial ribosomal proteins that are heavily upregulated in quiescent and chemo-resistant cells. And upon further analysis, these mitochondrial proteins do appear to play a role in causing chemo resistance. There's more to it than that, but for now we're attempting to experiment with these mitochondrial proteins in vivo mouse models to find more. So if there's one takeaway from this video, it's that the mitochondrion isn't just the powerhouse of the cell. Thank you so much for watching this video. And of course, thank you to my PI, Dr. Shobha Vasudevan, for supporting me throughout this project. My abstract and presentation slides are on this website, and of course, feel free to leave any questions or comments you have in the discussion box. Thanks so much, and have a wonderful rest of your day.